This is the second part of the 2.2 video. So I want to do a quick refresher on what we did last time. Let's say we had x squared, no, it's going to be bigger than that, x to the fourth minus 6x squared to the third plus 2x squared minus x plus 10. And we divided that by x minus 4. Okay. So I put x minus 4 on the left side of a box, and I won't know how long the box is until I get done. So if at any point you're confused, please stop me so I can maybe explain it in a different way. Because this isn't difficult, but if you don't understand the steps, you're going to be way lost. So first, I need to bring down this x to the fourth. And then I just fill in the missing information. If I take x to the fourth and I divide it by x, what's left over? X to the third. Does everybody understand that? I'm just pulling out an x, basically. And then x to the third times negative 4 is negative 4x to the third. And then I look up here, have I finished all of the numerator? No. So I add a column. And now these two boxes have to add to be negative 6x to the third. I have negative 4. What do I need to create a negative 6? Minus 2x to the third. Then rinse, lather, and repeat. Pull out an x, negative 2x squared. Negative 2x squared times negative 4 is negative 8x squared. Have I finished the numerator? No. So I add a column. These two need to add up to be 2x squared. I have 8, I need 2, so I subtract 6x squared, pull out an x. Negative 6x times negative 4 is 24x. Have I finished the numerator? No, so I add a column. These two need to add up to be negative 1. Minus 25x. So I pull out an x. Ooh. Wow. Can I change this? I can. You guys can't stop me. So, negative 25 times 4 is 100. Have I finished the numerator? Yes. I'm done. Okay. So, this polynomial divided by x minus 4 is the new polynomial x to the third minus 2x squared minus 6x minus 25. Okay. This went in evenly. What does that mean? No remainder. Okay. And what else does it tell us about the graph? So this right here is a W-shaped graph. Okay, and I don't know a lot about it. Something like this. It can have 4 roots. It might not have any, but it can have up to 4. Everybody understand that? And x minus 4 worked, which means x equals 4 is one of the solutions. Because it worked. It went in evenly. Okay? So, what do we know about the remaining equation, our answer? It's basically the same graph with this removed. And it's not really the same graph. It hits in the same places. So this graph here, this equation here, might look something like this. No, I wanted to... Won't let me change colors. There we go. The new graph might look something like this. Does that make sense to you guys? Okay. Now, let's go back. Okay. Let's say that was not 100. Let's say it was 95. So negative 4 times negative 25 is 100. Excuse me. Excuse me again. So, did I finish the numerator? No. So I need to add a column. These two need to add up to be 95. So what do I need? Negative 5. Now, can I pull an x out of that? No, it doesn't have an x. So anything that happens after here is a remainder. And we always treat remainders the same. We write plus, wait a minute, it says minus. Always write plus, and then write your remainder, negative 5, divided by x minus 4. So, this one had a remainder. What does that mean? It means x minus 4 did not go in evenly. It also means the graph does not hit the x-axis at 4. Does that make sense? Okay. And if I had something like 6/5, that's the same as 1 and 1/5. We refer to that as improper fraction, although I don't know why it didn't do anything wrong. Yeah, so this, the original problem, is the improper fraction. And the resulting answer, this stuff here, is the mixed number. And they're exactly the same. If you were to type them into your calculator and graph them, they will look exactly the same. Okay, so why do we care? Well, there are some things that this allows us to see that this does not allow us to see as easily. And hopefully it goes in evenly. If it does, then we can do lots of things with it. Does that make sense? Do you want to see another one before I go to the next step? Okay. Let's make one a little bit harder. And this, I might have to change the numbers as we go. Sometimes you have to fix things, but let's say I have 6x to the third minus 8x squared plus 10x minus 5. Now, I totally reserve the right to change that equation if this ends up being too hard. 2x minus 5. Okay. I put 2x minus 5 on the side, and I don't know how many columns there are, so I'll just draw that out. I bring down the 6. I pull out a 2 and an x. What am I left with? Everybody okay with that? And then 3x squared times negative 5 is negative 15x squared. We good? Add a column. So I've done this one. Wow. So I have negative 15. I need negative 8. So I will add 7x. Oh, see, that's a problem. Okay. So I have negative 15. I need negative 9. What? Add 6. Now I take out a 2 and an x. Okay. 3x times negative 5 is negative 15x. Oh, and I did it again. I have negative 15. I want negative 11. So I need 26. 26x. Is everybody all right with that? Okay. Pull out a 2 and an x. And then let's make this bigger. Oh, wait, that's we don't want that. So let's say minus 50. Okay, 13 times 5, negative 5 is negative 65. Is that what I was hoping for? No. So I add a column. I have negative 65. I need negative 50. So I add 15. Can I pull a 2x out of it? No, that's the remainder. So in ALEKS, you'll either write 3x squared plus 3x plus 13, remainder 15, or the better way to write it, which I don't think ALEKS does at the moment, is plus 15 over 2x minus 5. Okay, you guys get that? Now, there is a shortcut sometimes. Sometimes there's a shortcut, sometimes there isn't. So if the thing you're dividing by has a root that is an integer, there's a shortcut. So I wonder if I have any. Nope. So let's say I had this. Okay, and I wanted to divide it by something like x minus 2. Okay, if this has a root that is an integer, not a fraction, but a positive or a negative whole number, then we can do something called synthetic division. And synthetic division is super easy and it's super fast. The only problem is it doesn't always work. So for synthetic division, you find when does the denominator equal 0? At 2. So we write that down. And then I write out all of the coefficients of the numerator. 1, negative 6, negative 10, negative 2, and negative 5. Okay. And then I draw a big long line. And then we use this algorithm. It's the same process over and over. And explaining it's not going to make any sense. I'm just going to do it. You drop the first term. And then from then on, you just do the pattern of multiply, add, multiply, add. So 2 times 1 is 2. Then I add those. Negative 4. 2 times negative 4 is negative 8. I'm going to change that. 10 minus 8 is 2. 2 times 2 is 4. Negative 2 plus 4 is 2. 2 times 2 is 4. And then I get a negative 1. Okay? The last one is your remainder. Did this go in evenly? No. Okay, so I have a remainder. And now we can write the new equation by looking at the degree of the original equation and then making the degree of the new equation 1 unit smaller. So this becomes x to the third minus 4x squared plus 2x plus 2, remainder negative 1, or negative 1 over x minus 2. Okay, let me show you another one. And again, I might have to change it so the numbers don't get out of control. So I put 4 in the corner because that is the root associated with x minus 4. I write out all of the coefficients. 4, negative 6, 2, negative 4. Then the pattern is drop the first one, multiply, add, multiply, add, multiply, add until you get to the end. So we drop the 4. 4 times 4 is 16. Which gives me a 10. Ooh, that's a problem. Whatever. We're just going to go for it. So 4 times 10 is 40. 42. And 4 times 42 is 168. So I get a remainder of 164. That did not go in evenly, but what is the answer? Well, the original was an x to the third, so the new one is going to be an x squared. 4x squared plus 10x plus 42. And then plus 164 over x minus 4, or it might ask you to say remainder 164. Does that make sense? Okay, now I'm going to throw you a curveball. You do have to be a little bit careful with, well, with division in general, but especially with synthetic division. Okay, and let's divide that. Let's keep it simple. So, I put 1 in the box. What are my coefficients? 1. Who said that? Tyler, what's going on here? There is no x to the fourth. If I don't put it, is that going to create problems? Yeah, because my answer down on the bottom has to have 1 fewer exponents than the one on top. So the top one has x to the fifth, but it only has 4 terms instead of 6. So if I don't put placeholder zeros, then that's going to mess up mess up the calculations, and it will mess up my answer at the end. So we need to look for hidden variables. 1, 0, -6, 0, 3, -1. And the same is true if you do the box division, but it will be a little bit more obvious that you're missing something. I'll show you that in a second. So the pattern is the same. Drop, then multiply, add until you get to the end. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -5. -5. 1 times -5 is -5. So -2, -2, and -3. Did I do that right? Think so. And now notice I got I'm going to start with x to the fourth. So x to the fourth plus x to the third minus 5x squared minus 5x minus 2 plus -3 over x minus 1. So I got my 4 and my 2 back, which is a little bit weird, but that will happen. Okay. Now, what if you do regular division? How do you deal with that? So I put x minus 1 on the side. Actually, let me move this down a little bit. Okay. Bring down the x to the fifth. Pull out an x. Okay. Now these two need to add up to be... No, oh, sorry. This is a 4, and that's a 4. So my negative x to the fourth in that box need to add up to be 0x to the fourth, because there are no x to the fourths in the numerator. So this has to be plus x to the fourth. Then I pull out an x. Those two multiply together. These two need to add up to be -6. So minus 5x to the third. Pull out an x. Multiply. So those two need to add up to be 0. Pull out an x. -5 and -1 is 5x. These two, those two need to add up to be 3x. I have 5. I need -2 more. That times that is 2. Did I finish? No. So I add a column. Those two need to add up to be -1. So I subtract 3. And that's the same answer that we got before. Okay. Let me show you one more. So that's too big. Can I use synthetic division on this? No. And let me show you what happens when you try. You actually can, but it does mess things up a little bit. What would I put in the corner? -1/2. So that complicates things a little bit. 4, -6, 2, and -4. So drop the 4. -1/2 times 4 is -2. -1/2 times 8 is 4. And then that would be -3, -7. So we end up with 4x to the third, 4x squared minus 8x plus 6 plus 7 over 2x plus 1. Okay, and that's partially correct. But it turns out when I divide all of those by 2, then those numbers should be half as big as they're shown to be. So synthetic division, when this is a fraction, kind of works, but your resulting equation ends up being larger than it's supposed to be. If you cut a 2 out of those, now it's correct. So you can kind of do it, but what if the bottom was x squared plus 2x minus 3? That actually has 2 roots. It has -3 and +1 as a root. So which one do you put in the box? And the answer is you have to put both of them in, so it doesn't work. You can get by with just box division. You don't ever need synthetic division, but it is much, much faster. So I think today we'll just finish ALEKS 2.2, and then we can do this worksheet next time, because the worksheet's a lot harder. Okay, get to work.